Bonjour, students. This is Mrs. Trivet. Yes, and we are looking at Chapter 9, Lesson 2 today. This one's called Mean. Not being mean to people. This is the math version of the mean. This is something you probably have already learned about, but it's something that every single grade level reviews to make sure you understand it. So, page 398 in our green math books, and we'll start with our learning target again. All about the mean today. So today's learning target is I can find the mean of data sets. We're just going to go with that. I can find the mean of data sets. All right, here's our big word for the day, mean. So at the top of 398, we'll take a look at what that is. It says a mean is a type of average. So if you think of asking yourself, what's the average temperature in January? You're going to take some of the higher ones and some of the lower ones, and you have to kind of find the middle-ish. So here's how to do it. And this is the same thing I do every time when I find your guys' average for doing your notes on time in class. So the mean of a data set is the sum of the data divided by the number of data values. So you take all the values and you add them all together, and then you divide by how many you added. So there's a numerical example there on page 398. Let's go ahead and get the word in our notes. So here's the mean. So in words, we can say it's the sum of the data divided by the number of data values. So we have some adding to do because we see the word sum here, and we have some dividing to do when we're finding the mean. So now we'll go ahead and get right to our examples. They're going to start us out pretty basic with just practicing doing this, and then we'll get into some harder ones. All right, example 1, finding the mean. The table shows the number of text messages sent by a group of friends over a week. What is the mean number of messages sent? So there is a little chart there with some different numbers. So we'll go ahead and get that in our notes. This is text messages sent. Now, in this chart, if you're looking at your book with me, you'll see there's names attached to these numbers. I'm not going to really worry about those names. We're just going to write down the numbers here. So one person did 120 text messages. The next person sent 95. Then we have 101. Then we have 125. Then we have 82 text messages, 108. I almost said 180. And then we have 90 text messages. So those are all of our numbers in our data set. To find the mean, over here, find the mean, we're going to add them all together, and then we're going to divide by how many there are on our list. So we'll have a big number sentence here, 120 plus 95 plus 101 plus 125 plus 82 plus 108 and plus 90. And that entire answer we get, I'm going to put this big fraction bar because remember that means division. We're going to divide it by how many there are. So there are 1, 2, 3, 4, 5, 6, 7 on our list. So after we get that answer on the top, we will then divide that answer by 7. So this gives us our math work here. And if we add all those together, our magical answer here is 721. So we have 721 divided by 7. And when we do that division, we end up with a whopping 103. So our mean is going to be 103 text messages. And what does this mean to us? Well, that means that some people on this list texted more than that, and some people texted less than that, but 103 is our average, our mean. All right, let's take a look at example 2. All right, let's choose green here today. So scrolling down here. All right, example 2, comparing means. So remember, when we compare something, we have to have more than one of something, and looking at the difference between the two. So this is the double bar graph, shows the monthly rainfall amounts for 2 cities over a 6-month period. Compare the mean monthly rainfalls. Okay, so this would take us forever to write this graph in our notes. So we're going to kind of shorten this down to make it a little bit more note friendly. So we're going to write double bar graph. And I'm going to put in the book. So we remember that we didn't draw this in our notes. It was in our book. And it's showing the monthly rainfalls. So we're going to put monthly rainfall amounts. Okay, so we have 2 things we're comparing here, okay? And there's 2 different cities, and they're just named City 1 and City 2. If you look at your bar graph, City 1 in the little key is the dark green color, and City 2 is in the light green color. So I'm going to make a little chart here for City 1, and then over here we're going to have City 2. Okay, so we've got City 1 and City 2. So let's just focus on City 1 first and list all of those numbers. Those are going to be the dark green bars. So we have City 1, 3.5 inches of rainfall. Then we have 2.2 inches of rainfall, 1.9, 2.1, 2.5, and 3.4. Okay, City 2 is the lighter green bars, so let's list their inches of rainfall. 1.7, 1.6, 2.2, 2.1, 2.7, and 1.7. So those are the inches of rainfall that I just took from the bar graph. And so when it asks us to compare the mean monthly rainfalls, this word compare right here, we have to find both of the means and figure out kind of which one's greater, which one's less. So we're going to start with City 1. So for City 1, we're going to add up all of our values and then divide by how many values there are. So we have 3.5 plus 2.2 plus 1.9 plus 2.1 plus 2.5 plus, I'm running out of room, 3.4, and that entire list, there's my division bar, is going to be divided by 1, 2, 3, 4, 5, 6 different values. So waving my magic wand, adding up all of these decimals would give us 15.6 as our addition answer, our sum, and we're going to divide that by 6 total data values, which gives us a whopping 2.6 inches for our mean. Okay, there's City 1. Let's go over here for City 2 and do the same thing. So we'll add up those values. So we have 1.7 plus 1.6 plus 2.2 plus 2.1 plus 2.7 plus 1.7. And that entire list is also going to be divided by 6. 1, 2, 3, 4, 5, 6. If we would wave our magic wand and add all of those decimals together, we actually get a whole number. It's kind of nice. We get a 12. 12 divided by 6 total data values would give us a nice number of 2. So now if I'm going back to our question, it says compare them. Well, I found both of the means, but I need to write some kind of comparison statement. So it looks like City 1's average is 2.6 and City 2's average is just 2. So we can say for our comparison statement that City 1 has a higher average or mean rainfall because 2.6 is higher than 2. And we're done with example 2. If you want to pause the video now and try the on your own, they're on the next page at the top. There's an on your own 1 and 2, and it just says find the mean of the data. So go ahead and practice those. Okay, if you decided to practice those, your mean for number 1 would be 57, and your mean for number 2 would be 7.5. We're now going to get to another vocabulary word. So let's go back to blue, actually, so we can list this vocabulary word. We're going to have to start a new page as well. If you look at kind of the top of 399, the highlighted word there, it says outlier. An outlier is a data value that is much greater or much less than the other values. When included in a data set, it can actually affect the mean. So we'll write down that word, outlier. Some would say I'm an outlier. A little bit odd, a little bit crazy. So it's a data value that's much greater or much less than the other values. So we can kind of sum that up by saying it's a data value that's far away from the rest. So all of your data is around one area, and then you've got this random one kind of out on its own, and it can be higher or lower. It doesn't have to go one way or the other. So now thinking of that word, we have one more example to try out. So we'll skip over to our other color. Here we go with example 3. Finding the mean with and without an outlier. It says the table shows the heights of several Shetland ponies. Oh my gosh, those are cute. They're on the left-hand side there. And you got a little table there, and these are all the numbers in inches, the table says. We're going to identify an outlier first. Then it says find the mean with and without the outlier. And then it says describe how the outlier affects the mean. Okay, so we're going to do 3 answers. Let's write down our chart. These are Shetland pony heights. Very cute little horses there. Let's jot down these heights real quick. We've got 40. We've got 38. We've got 37 inches. We've got 38 inches. We have a 39 inches, a 37 inches, 40, 28, 42, and 40. Now, one way to identify an outlier, if you don't have too many values, is to make a dot plot. If you make a dot plot of this information, you can easily see if one of your dots is kind of far away from the rest. So we know what a dot plot is from our last lesson. So let's just do a quick one here for this guy. If you look here, it looks like our lowest value is 28. Highest value looks like 42. I don't know that I have enough to go by ones here, so I'm going to go by twos. So it'd be 30, 32, 34, 36, 38, 40, 42. I'll just keep labeling even though I don't need these higher values. Okay, so there's my numbers here. Remember, these heights of the ponies are in inches, right? Just to kind of give us an idea. So let's put our dots on. We have a 48 and a 38. Oh, we did need to go to 48. Good thing I did. That's not true. This one here should be 40. So that should not be. This is going to be a 40. I wrote that down wrong. There we go. Okay, so our first one is a 40. Then we have a 38. Then we have a 37. That's going to be right in between here. 38, 39, 37, 40, 28, 42, 40. All right, let's take a look at our dots. We see this nice cluster here. Lots of dots here. And then, oh, look at this guy. Whoop. That guy is all by himself. So if we look at our definition, a data value that is far away from the rest. So A says display and adopt or identify an outlier, excuse me. So we can say our outlier is 28 inches. That guy is far away from the rest, that's for sure. B says find the mean with and without the outlier. Okay, so we're going to find the mean twice. We're going to find the mean with this number included in it, and we're going to find the mean as if this number was not there at all. So we're going to say mean with outlier. Let's find it with the outlier. So we're basically going to just find the regular mean of all of these. So we're going to add up all of our numbers and divide by how many there are. So we have 40 plus 38 plus 37 plus 38 plus 39 plus 37 plus 40 plus 28. I'm running out of space. Plus 42 plus 40. That's kind of ugly, but we're going to divide this whole thing by how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 of them. Bam. If I waved my magic wand and I added all of those together, I would get 379 for the top value. And then I have to divide that by 10, which ends up giving me 37.9 inches. Okay, that's our mean with our outlier included in our data set. Now we're going to find the mean without the outlier. We're basically going to do the same thing, but we're not going to put in that 28 this time. So technically, we could be smart about this. If we know that all of the numbers added together are 379, we know that all of them added together take away the 28, it's going to give us our new top number. So if we did 379, take away the 28, that ends up giving us 351. Okay, so if we add them all together without the 28, we would have 351 total inches. And now this time, if we think about it, we don't have 10 on the bottom anymore because there's not 10 values anymore. We took away this one right here. So instead of 10 values, we have to divide by 9 values. So when we divide by 9 values, we end up with 39 inches. So we just found our mean with our outlier and got 37.9. Our mean without is 39. So that is a difference. There is some sort of difference there. And so C is asking us to describe how the outlier affects the mean. Well, with the outlier, our number is a little bit lower. Without the outlier, it's a little bit higher. So we can kind of generalize that in a sentence. We can say, with the outlier, our mean is lower. So it does affect it by a couple different inches there. So that could be a general statement you can make. So that's our lesson. Pause if you want to try the 2 on your own at the bottom, numbers 3 and 4. If you tried those ones out, it says for each data set, identify the outlier and then describe how it affects the mean. So number 3, the weight of 8 pounds would be the outlier there. And if you found the mean with and without that 8, it makes the mean less than all but 2 of the weights. And then number 4, the outlier there would be 900. And it makes the mean greater than all the other prices. So it kind of brings everything up on that one. That's if you try the on your owns. And that's our second lesson in chapter 9.